by M2. So what is M1 going to do to M2? So how does it look? The opposite way. So basically, this is going to be F sub G as well. So basically, we have Newton's third law acting here. This is Newton's law of gravitation. But when a force acts on a body, that body is going to act on that body that's acting on that. when a force is acting on something, the thing that is acting on will apply a force to it as well. And it's all going back to this balance thing. Things remaining in balance. Okay? So Newton's third law. I remember when I remember staying at when I was a bachelor. I basically had a room with a fireplace, and I had my little throne chair and all of that, and I just had the fireplace burning. And I think that was where I was, but it doesn't matter. I burned a log of wood so fast in there. It was like pine. It burned so fast that it maintained its shape, okay? Even though it was ash. Now, when I grabbed the wood, I was able to pick up the wood because the wood exerted a force back on my fingers, okay? And this is to illustrate Newton's third law. When I saw that ash, I was like, man, I wonder, can I pick it up? Guess what happened when I tried to pick up the ash that looked like the wood? It crumbled, it disintegrated. It did not exert a force back on my fingers. Thus, there was no equilibrium. There was no balance. Do y'all follow what I'm saying? It's almost, it's like, it's so much common sense that's wrapped into it, huh? No, it had down. It was enough force for the ashes to stick together. You know what I'm saying? But it wasn't enough forces for me to pick up those ashes and maintain its form. So the log itself, which was no longer a log, but it was just total ash, it disintegrated in my hand. And you guys will see that this is a primary function to building all kinds of things. When I step on this floor needs to do what? It needs to push back at the same rate that I'm stepping on it. Does that make sense? Even when you open up your door here, it was a trick that we used to play when I was doing construction. If I would take the screws out of this doorknob and I closed the door and someone was in the room and they try to open up the door, they pull the doorknob off. And when they pull the doorknob off, they can't really get out unless they know how to get out. They had to go and get a screwdriver and then, do something with the lock and stuff. But now this doorknob, even though the doorknob itself is strong, it's not attached to the thing that I want to move. So I'm trying to apply a force to the door. Y'all follow that? Okay. So that's Newton's universal law of gravitation. It in a nutshell. Okay. So if I have the Earth here, okay, and I place a little mass here, and this mass is 1 kilogram. Let's just call that a test mass. I want to apply that equation to this. So the mass of the Earth. Did we do this calculation? What's the mass of the Earth? What's the radius of the Earth?